This is Josh White with JW Math Tutoring. In today's video, I'm going to go through 11 problems from the May 2025 Digital SAT Math exam. So let's go ahead and get started.
But life is a dream that calculus could never predict.
Just before I get started going through this third set of problems from the May 2025 Digital SAT Math exam, I want to mention a couple things. Of course, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, if you haven't done so already, please do check out the first two videos and the worksheets associated with them. There'll be a link in the pinned comment on the video below. Third, these are problems that I compiled primarily from Reddit. So some of them may be missing information that was provided on the test. If you receive this problem as an official exam problem. So just keep in mind, I've tried to recreate them as best as possible, but some of them might be slightly different than the version you saw on the test, because again, I'm just going based off what students who took the test remember. I don't have an actual copy of the test in front of me to reference. And related to that, most of these problems are going to be done as free response questions or student-produced response, but they may have been multiple choice on an actual exam. So if they were multiple choice, just keep in mind there could be additional methods you could use to solve them, which are probably not going to apply here because I'm doing pretty much all of them as, like I said, free response questions. All right, so with all that being said, let's go ahead and get started here with this third set of problems from, again, May 2025 official exams, the math section. All right, the first one is this one that asked for cosine p over sine p, basically had an angle on the unit circle. And essentially what's going on here is, okay, if you draw, say our circle looks like this, all right, and we have basically O is right here at the center. So like say here's your x-axis, here is your y-axis, x and y. Okay, and so right here would be O at 0, 0. Out here at 1, 0 would be A. And then technically down here on the unit circle would be something like this. Now, what I'm going to do is, here's point B, sorry, draw the angle that we have here, angle AOB, okay, AOB. So it's this angle right in here. And they're asking for, this is the angle, in other words, that measures p radians. And they're asking for the value of cosine p over sine p. All right, now, the problem is it going to be a positive value or negative value? So most unit circle questions, you just, we instinctively know that the cosine associated with the angle is just the x-coordinate of the point, which in this case would be 5, and then the sine of the angle is the y-coordinate associated with the point, which in this case would be negative 8. And that's because, you draw a right triangle, you can see that the cosine is going to be the x for the angle, and sine is going to be basically the x or the adjacent, sine is going to be the opposite or the y. Okay, the problem is, though, technically when you're dealing with a unit circle, we're dealing with an angle that starts here, right, and would be going all the way around. In other words, you're talking about, in this case, a quadrant 4 angle, an angle that is between 3 pi over 2 and 2 pi radians. However, the actual angle we're dealing with is this small angle right here, which is less than pi over 2 radians, i.e. less than 90 degrees. So my initial thought on this was that the answer would be positive, because the angle itself is less than 90 degrees. It's less than pi over 2 radians. And, any angle between 0 and pi over 2 radians has a positive sine, a positive cosine, positive tangent, because it's essentially equivalent to a quadrant 1 angle. However, after talking this over with one of my friends who's also a math teacher, the fact that it is labeled or named as angle AOB seems to indicate that the angle will in fact actually be a negatively drawn angle. What I mean by that is, and let me just clear out some of the stuff here. So like tracing it out the way I did originally, AOB, it starts here and it goes down in the clockwise direction, which would make it negative. Therefore, that would make this that would make the answer negative here, because the excuse me, the sign in quadrant 4 is negative, and therefore the answer would be just this negative 5/8, or you could also put as a fraction negative 0.625, or you could also put the 0 in front of it as well. But regardless of how you want to write it, because of the fact that it's named as AOB, meaning starting here and going down here, that would seem to indicate that it is drawn, again, in a negative direction like this, which would mean that, yes, it will have a negative sign value. In other words, this is a quadrant 4 angle, is really what it is telling us in terms of its cosine and its sine. That means the sign will be negative, therefore it will be, positive 5 over negative 8. So therefore, correct answer for this one would be either one of these, and I believe it should be negative. All right, next up, question directly below it, number 2. So for this problem, you're given an equation. It's basically essentially, it's like the vertex form of a parabola, quadratic equation. And you're told it has no real solutions. What is the greatest value of t? So here's the thing. Basically, if you think about this, in order for this problem to have no real solutions, if you went ahead, okay, don't worry about the h here, but moved the two constant terms, the two number terms, over to the right, so it becomes 2t minus 27. Okay, in order for this to have no real solutions, basically this expression on the right must be less than 0. So if you try to go ahead and solve this, basically you divide by 8, and then you would go ahead and you square root both sides. But on the right side, if you have a number which is less than 0, then it's going to be a negative value, and you square root that, it'll give you a complex number, i.e. no real solutions. And since that is what you are looking for, this is the inequality we want to set up, basically. We want a negative on the right side for this problem. So you just set up this inequality, you go ahead and solve it. Get rid of that, plus 27 on both sides. And then you get 2t is less than 27, divide by 2, t is less than 13.5. Of course, that's not an integer, so the largest or greatest possible value of t is just going to be 13. Now, of course, we can go to Desmos just to solve this entire thing out or verify it. And basically, Desmos, what we're going to be looking for is a vertex of this parabola. Now, first of all, for h, that technically is not going to matter. That's just the x-coordinate of the vertex. That just slides it left and right, wherever you put for that. So whatever, I'm just going to put 5. We're looking for the vertex of the parabola to be, since this one opens up, we're looking for it to be above the x-axis. Okay, that will give us no real solutions. So notice we have that right now, but we want to see how big can we make t in order for that to remain true. So notice I slide this all the way out to 10, it's still not there. Okay, so let's jump it up to 20. Also, because it tells you that they're integers, I can just change the step value to 1, so I don't have to scroll through all the decimals. So 11, 12, okay, 13. Notice it's still, there are still no real solutions. I do not have any x-intercept values. However, notice what happens when I jump to 14. Now I do have 2 real solutions, i.e. 2 x-intercepts, 2 zeros. 2 real zeros, so on. So this just confirms the largest integer value for t here is going to be 13. All right, let's look at problem 3 at the bottom of the page. This is a geometry problem where we have some parallel lines. So in this diagram, notice that A and B don't appear to have any type of relationship in terms of like a special pair of angles. However, A is a vertical angle to this angle right here, so this angle will also have the measure of A, the 3k plus 93. Now we have a pair of same side interior angles, A and B, which means they're going to be supplementary. They will add up to 180. So 3k plus 93, which is A, plus k over 4 plus 48 adds up to 180. Now, just to save time in terms of solving this out, I'm just going to go straight to Desmos. And because it's in terms of k, I can just go ahead and just do a regression. All right, so if you solve this equation out, and again, you could do this by hand if you wanted to, or you could just type the whole thing out, but just change k to x and make it an equation and look for the vertical line. K is going to equal 12. So now, how do we find C? So basically, all we're going to have to do is plug in the value of 12 to find the measure of angle B, and then essentially subtract that from 180, because B and C are supplementary. That's one method. Or, if you notice, A and C will actually be congruent, because here these two are corresponding angles. Or, if you look at this one and this one, they're technically alternate exterior angles. So, however you want to do it, you can either, again, you can do 3 times 4, not times 4, 3 times 12 plus 93. That's going to be 36 plus 93. That should be 129. That is going to be our answer, by the way, 129. Or you could technically plug it in for B. 12 over 4 is 3. 3 plus 48 is 51. And then do 180 minus 51, which is going to be 129 as well. So however you want to work it out, measure of angle C turns out to be 129 degrees. Okay, moving to the top of the next page. Question number 4 here. So this one, basically, it's just a percentage problem. You know, it looks like a word problem, but it's really just like I said, a basic percentage problem, where you have this calcium concentration for tap water, bottled water, and mineral water, and all related by various percentages. So essentially, what's going on here is calcium concentration in bottled water, which I'm going to call B, is 44% that of tap water. Okay, 44% tap water. Calcium concentration in bottled water also is equal to 20% concentration of mineral water. So we can set up this second equation as well, 0.20 m. Now, what do we want to know? We want to know the calcium concentration of mineral water. So essentially, we know that the tap water is 32 milligrams per liter in terms of its concentration. So all we're going to do is just replace this with 32. And then when you go ahead and multiply that out, I believe it comes out to 14.08. And now that is the value of B, the calcium concentration of bottled water. So you can just replace B with that in the second equation. And then you're going to divide both sides by 0.20. And that's going to give us the concentration for mineral water. All right, so let's just confirm that the initial calculation was correct. Yep, 14.08. And now we just need to take that and divide it by 0.2. And it comes out to 70.4. So that's the correct answer. Calcium concentration of mineral water is 70.4 milligrams per liter. Now, let's see how you could do this entire thing in Desmos. So, first thing I'm going to set up is the relationship between the bottled water and the tap water, just like I did writing it out by hand. Then I'm going to define the tap water to have the 32 milligrams per liter, no units of course. And then lastly, you can just do a regression for the bottled water related to 20% of mineral water. And notice in one step, not one step, I mean 3 lines, but essentially once I type this third line in the regression, it gives us the mineral water value of 70.4. And that's how you could do this in Desmos. Again, typing this whole thing in took, maybe 15, 20 seconds. All right, next question, number 5. This is a repeat problem. This was seen previously last year. I don't remember the month. I want to say August. But it's been a while since you've seen this one reported. You have this square root expression with a radical term underneath it, and it's equal to r plus root p. What is, okay. So first thing, I will just tell you, the shortcut approach to this is basically it's going to work out as follows. The number under the radical is the p. So in this case, p is 7. And this number in front of the radical term here is equal to 2r. So r is just 21. So r plus p is 21 plus 7, which is 28. And that's your correct answer. It always works out like that, just because of the way this problem is set up. Now, to show you why it works out like that. So if you take, basically what happens is you square both sides of this equation. If you square the left side, well, then you just have, the 448 plus the 42 root 7. Again, squared. On the right side, you have to FOIL it out, right? So it's r plus root p times r plus root p. R times r squared. The inner and outer terms are the same. They're both r root p, and so when you combine them, you get 2 of them. And then root p times root p is just p. Okay, so now you can basically match up the like terms. So this has to match up this. Okay, basically the p has to equal 7 and 2r has to equal 42. So that's where it comes from, really. And I mean, you can take r squared plus p and, 448, and you can match that up, and, given that p is 7, you can subtract that, and then you can, square root that and get r that way too, but it's just so much quicker to notice, the middle term, basically the middle term on the right side matches the radical term on the left. So that's it. That's the answer. It's 28. Alternate way you could do this too in Desmos, probably not the quickest way, but what you could do is if you take the expression on the left and you just type it in, notice it's less than 23, it's 23.645. Okay. Therefore, the value for r has to be something less than 23. Okay? Because if you plug in anything greater than that, it wouldn't make sense. If r was 24, it'd be impossible to add another positive number to it and have that equal, 23 something. So r has to be less than 23. So basically, what you do is, okay, we take this expression and we do a regression. And now, I'm going to set a slider for r. I'm going to start at 1. Okay, I'm going to set the step value to 1 because both of these are integers. And what I'm going to do is I'm going to slide it up to 23, and I'm going to see, when I do that, where do I have a pair of integer values? So really what I'm looking at is I'm looking at the p-value in the regression. Don't worry about the graph on the screen. We can turn that off. That's irrelevant. Notice, still no integer for p along with r. 18, 19, 20, and then eventually when you get to 21, here is the pair of integers, 21 and 7. So this is an alternate way you could do it. Again, it's not I don't think it's the fastest way, but it is an approach that you can take. All right, bottom of the page, question number 26. Here we have a repeat problem. This is on the Blue Book practice test. This is also on previous official exams as well. This one is a multiple choice question, typically, and we have an isosceles right triangle, meaning it's a 45, 45, 90 right triangle. We know, and this is the perimeter. We want to know what's the length of the hypotenuse. Okay, so there's multiple ways you can solve this. First of all, you could back solve this. You could go through the answer choices, and you could say, like, okay, if this is the hypotenuse, what are the side lengths? You know, and then like work it all out and go from there. So, I mean, I already know what the answer is, so I won't bother going through all the incorrect ones, but a lot of people think it's going to be 43 root 2. And if that's the hypotenuse, that means the sides would each be 43, because to go from hypotenuse to side, or to leg, in an isosceles right triangle, you divide by root 2. But notice if you add this up, you get 86 plus 43 root 2. So that's wrong. That's not the correct answer. All right? And it's actually going to be letter C. It's going to be 86. Basically, these sides are 86 divided by root 2. Or if you simplify this, it just becomes 43 times square root 2. So then when you add everything up, you get 86 plus 86 square root 2. So if you're doing this by hand, that's the approach I would take. However, you can actually figure this out very quickly and very easily in Desmos using regression. So think about a 45, 45, 90 isosceles right triangle. Say this is A, this is A, this is A root 2. You could use, whatever letter you want. We know that A plus A square root 2 okay, when you add those all up, is equal to 86 plus 86 square root 2. All right, so it gave me a value for A here. Now, here's the thing you have to be careful with. A is not the length of the hypotenuse. A is the length of one of the legs. So for the hypotenuse, we just need to type in A square root 2, and that's going to be our answer. And now notice we get 86. It's letter C. Again, very, very quick and easy way to do this problem entirely in Desmos. All right, next up, question number 7. This is a repeat question. This first appeared, I think, way back in May or June of last year. This equation has one real solution, and they want you to find the value of C. So, if you're going to do this by hand, I'll show that method first, then I'll show the quick and easy Desmos method second. You would go ahead and you would multiply everything on both sides by 92cx, basically the common denominator, and that would give you 92 equals 92x plus cx squared. All right, and now I'll just turn this into 0 equals cx squared plus 92x minus 92. Okay. At this point, get rid of this, there's two different approaches you could take. So you could use the discriminant, which basically tells you, since there's only one real solution, it's going to be equal to 0. So b squared minus 4ac will equal 0. And that's going to be 92 squared minus 4 times c times negative 92. So now you go ahead and you multiply this out. You get 8464 equal to 368c. And then, of course, you could just divide by 368. And that's going to give you a C value of negative 23, which is the correct answer here. Now, alternate approach you could take as well is once you do the multiplication and you get the quadratic, just go to Desmos and use a slider. And basically what you're looking for is exactly one real solution. The problem is, so it's like if you start going to the positives here, like even if you jump it up to some very large numbers, it's never actually going to get to one real solution. So you have to basically realize that it's going to be a negative value and essentially flip it so it opens down. And then eventually, let's zoom in here. Yeah. Let me just, there, send this back. So notice eventually here as we slide it further and further down. Okay, so you see there we went too far. It looks like I might have to just type it in there. Negative 23, you can see, is exactly on the x-axis. Therefore, there is one real solution. Therefore, that's the correct value. Now, they don't tell you in the problem that it's an integer, so you can't just set the step value to 1 and assume that it's necessarily an integer. Now, there is a method you can use to solve this, though, completely in Desmos. It is very quick. It is very easy, but there's one thing you have to keep in mind. So all I'm going to do is a regression. And of course, when we do a regression, we have to put a list in for x1 because we want to find the value of c, right? We want x1 to be treated as a variable, not as a constant. However, what you need to do is only put 2 values in the list. I don't know why Desmos works like this. If you only put 2 values in the list, it will give you the correct answer to this type of equation every single time, even if you change, even if it's not 92, if it's some other number and gives you a different answer. If you put more than 2 items in the list, which normally we do for some regressions, then something happens. It's not giving me the correct value, right? It's giving me something different. You only put 2 items in the list, and that will give you the correct value. And right here, you can see it. It is negative 23. All right, let's move on to the next problem. Number 8, here we have a rectangular prism where it gives us the height, and it gives us the length of one of the sides of the base, and also an expression for the area of the base that has a letter T in it, 27T basically. All right, so if you just sketched out a quick picture here, this area down here, okay, this yellow is equal to 27T. We know the height is 14/3, and we know one side of the base, let's just call it this one, is 3. So we want the total surface area of this prism. In order to do that, we need to find this missing side. We'll call it the length. So we know that the area of the base is 27T. And we also know the area of the base is, of course, just L, the length, times this other side, that's 3. Therefore, if we go ahead and solve this, you're going to get the length, just divide by 3, equal to 9T. Okay, so this side right here is 9T. Now we can just go through, 2LW plus 2LH plus 2WH, and basically add everything up and get our answer. Also to note, of course, this problem would be multiple choice. This is impossible because the answer is going to have a T in it. It's impossible for this to be a free response question. But I don't have all the different answers that were given, so we're just going to do it as a free response question anyways. So notice, first of all, length times width, this right here is just the b, the area of the base. That's the 27t that we already know. So basically we have 2 times 27t, and then the length times the height, 9t times 14 over 3, and then the width, which is 3, times the height, which is 14 thirds. So let's see, what do all these things work out to? 2 times 27 is 54t. Here, 3 goes into this 3 times. 2 times 3, excuse me, is 6. 6 times 14 should be 84, and we still have a t in it. And the last one, the 3's just cancel out. We should get a 28. So the final answer that I get for this problem is 138t plus 28. Now, just so you know, since this would be a multiple choice question on the test, what you could do as well is you could pick a value for t, just like let t equal 1, all right? And then go through and work out the entire problem, and your answers are all going to be numbers, not expressions. So for example, this would be 54, this would be 84, and this would be 28. So you just add up all those values. All right, so you get 166, right? Then you go to your answer choices and you plug in 1 for t to each of them, and you see which of these 4 answer choices is equal to 166, and that's going to be your correct answer. So that's the approach you could take on the test where you have the actual multiple choice answers in front of you. Also, the last thing to point out too on this one, this is a repeat question. This has shown up before. Not that recently. I think it was back in 2024. All right, next up, bottom of the page, number 9. This is actually a brand new question. This is a tricky question. And the approach that I would take is as follows. Excuse me. So, if you want to do this by hand, I will show you here is how you have to approach this. First, if you plug in 0, notice that 0, 0, 0, you're going to get basically the square root of c equal to 24. That means c has to equal 576. So now you can go ahead. First of all, put the 576 at the end. Now you can plug in the 9, all right? So let me just erase this so we can see the original problem. So we've got 9 cubed plus a times 9 squared plus b times 9, okay, plus 576. The only way that I've seen to solve this is basically because you're trying to figure out what 9a plus b is equal to, is to do the following. First, factor a 9 out inside here. You get 9 squared plus 9a plus b plus 64. Okay, and again, this is also equal to 0. Now, this 9 in front, you could technically remove this. Like, you could bring this outside as a 3. But technically it doesn't matter because you divide by 3 on both sides, and 0 divided by 3, it's still 0. So this 9 that I factored out, you can technically just ignore that. That part doesn't matter. Now, here's the whole trick, or here's the whole key. Okay, this whole thing under the root has to equal 0, right? Therefore, so I'm just going to get rid of the root and write it like this. So this whole thing equals 0. So what does 9a plus b have to equal? Well, you subtract over 64. You subtract over this, I can rewrite now as 81. So 9a plus b, I'm just basically separating those terms on one side, is equal to negative 64 minus 81, or negative 145. And that's it. That's your answer. That's how I know. This is the only way that I know of to solve this algebraically. If you have any other suggestions or methods, Again, how to do this by hand, feel free to leave them below. Now, here's how we could do the entire thing in Desmos. Excuse me. So again, because this has this radical in the problem, you have to recognize initially that, again, C is going to be 576 and type that in before you can do your regression. So here's what I mean. I'm going to type in our 2 points to a table. Then I'm going to do a regression, but it's only going to work plus ax1 squared plus bx1. It's only going to work if I replace C with what I know it's equal to, which is 576. Okay? If you don't do that, if you just leave it as C, then it gets all haywire and it doesn't give you the correct answer. See, this r squared is, is awful. It's wrong. It's not accurate. So you have to put the 576 in. Now, it's given us values for A, it's given us values for B. We have the perfect r squared value of 1. So all I have to do is type, what's 9a plus b? Right here, negative 145. So this is how you could do the entire problem in Desmos using regression. But again, you have to be able to recognize that when you plug in 0, the square root of C is 24, which makes C 576, and type that in. All right, top of the next page, question number 10. This is a monster of a problem. I'm not going to lie. So basically, you have two quadratics here, and each quadratic obviously has these each have two solutions. One is larger than the other. Then you take the solutions, you end up adding them together, and those two new numbers, two new values that you get are solutions to a different quadratic, and that different quadratic that you get has a constant in it, and they want to know what the value that is. Okay. So first I will show the method by hand, then I'll show you how you could do it using Desmos. Because it's such a long problem, I'm probably going to skip some steps and try to just go through it as quickly as possible. So okay, first thing here, if you want to, actually we could I'm going to complete the square. Rather than quadratic formula, I'm just going to show you completing the square. So b value is 10, half of 10 is 5, 5 squared is 25. So I'm going to add 25 on both sides, and then this gets factored as x plus 5 squared equals 5. Square root both sides, plus or minus root 5. X equals negative 5 plus or minus root 5, okay? Those are the two answers to the first equation. R is less than S. That means that R is the negative 5 minus root 5, and S is the negative 5 plus square root 5. Okay, now let's repeat the second thing, the second equation. So it's going to be x squared plus 10x plus blank. We already know it's going to be 25, negative 5 plus 25. X plus 5 squared equals, this one is 20. It's going to be x plus 5 equals plus or minus root 20. X equals negative 5 plus or minus, and the square root of 20 I will simplify to 2 root 5, because it's 4 times 5, and the square root of 4 is just 2. All right, so now let's just see which, okay, t is the smaller, so that's negative 5 minus 2 root 5. U is negative 5 plus 2 root 5, the larger. Okay. Now we have to find the values of, let me just see here, r plus u and s plus t. Okay. So, r plus u. Negative 5 plus negative 5, negative 10. Negative root 5 plus 2 root 5 plus root 5. All right, not that bad. S plus t. Negative 5 plus negative 5, negative 10. Positive root 5 plus negative 2 root 5, negative root 5. Okay, I got a nice pair of, like essentially kind of like say the conjugates, even though these aren't complex numbers, but so these are my two solutions to my new problem. All right. So now the way that I actually go through and set up the new problem is basically as follows to solve for c. Let me just slide over here. So if I go through, again, completing the square, minus c plus blank, 20 divided by 2 is 10. 10 squared is 100. So I'm going to add 100 here, add 100 here. This becomes x plus 10 squared. Over here we get 100 minus c. Okay? Now, notice you square root both sides. X plus 10 equals square root plus or minus 100 minus c. X equals negative 10 plus or minus 100 minus c. All right. So notice this is what you get if you do completing the square on this equation, and my answer choices should be of the form negative 10 plus or minus square root 5. So now, matching up the corresponding parts, this equals this. 100 minus c equals 5. Negative c equals negative 95. Divide by negative 1. c equals 95. That is the correct answer. This is a ridiculous amount of work. This would obviously take, 2 minutes, 3 minutes, probably even longer than that on a test, writing this whole thing out. But the correct answer, which I'll just put over here, slide over here, is 95. Now, here's how you can do some of the work. Here's how you can do it in Desmos. It's still going to be a fair amount of work, but just, whatever. I'll go through the process and show you. So I'm going to take the first equation, going to do regression, and I get one answer here, and then I'm going to copy this. But what I'm going to do is I'm going to set, I want x1 to be less than that. Okay, so I have my two answers here, right? I can't carry these answers over. Even if I used R and S in these equations, I could not carry them over to do another regression statement later. So I'm just going to have to estimate them, and you'll see it's actually going to work out fine. All right, R is less than S. So R is the smaller number, which is the negative 7.23607. So we can define that. First of all, get rid of that graph. Then the other one is S, which is negative 2.6393. Okay. Let's move on to the second equation now. All right, so let's see. I think the other one's going to be less than this. Actually, no. What am I doing? First, sorry, I want to copy this. There we go. Second one is the one here where I want to make it less than that. Okay, perfect. So here are my two answers for the second equation for t and u. Okay, t is the smaller one, so that means t is equal to the negative 9.47214. S is the larger one, not S. U is the larger one. U is, I'm just going to slide this up just for a second so I can copy it down. Negative 0.527864. All right. Now, I got to do R plus U and S plus T. R plus U, S plus T. All right, so I have these two values, right? These are these are the two solutions to the new equation. So I'm going to call this A, and I'm going to call this B. And then what we're going to do is we're going to go to Desmos and we're going to do a regression where I'm going to say, okay, x squared plus 20x plus c, the original form, the equation I'm looking to solve, that is going to be regressed with x1 minus a and x1 minus b. Let me just clear. there we go, some of this stuff out. All right, now basically what I'm doing here is I'm taking the original standard form version of it, and I'm just regressing it to its intercept form or to its factored form, because I know the factors or the solutions basically are like, r plus u and s plus t, so the factors are going to be x minus parentheses r plus u and x minus parentheses s plus t. Now, you can already see here it's 95.0004. Technically, though, I do need to define x1 as a list. Now, I don't know why the residual doesn't... Oh, I know why. The residual doesn't work out exactly even. It doesn't give you exactly 95 because I had to estimate up here for r and s and t and u. Because I don't have the full exact decimal value, that's why it doesn't work out to exactly 95. But the thing is, even if you had to round it off here, it's 95.00. That's the same as 95. You're still getting the same correct answer. So in any case, this is how you could do it in Desmos. As you can see, it's still a fair amount of work, but you can do it a little bit quicker. All right, let's look at the last problem here, number 11. This is a fairly basic short problem. You have a right triangle. Angle R is the right angle. So we'll just put Q up here. We'll put S here. RS is 32. Which of these expressions is equal to the value of QS? So first of all, notice all these involve Q, this angle at the top here. So we're looking to relate RS, which is the side opposite, and QS, which is the hypotenuse. So of course that's going to be sine. We know that the sine of Q will be equal to the opposite, which is RS or 32, over the hypotenuse, which is QS. So now you could just cross multiply this, and then you could just divide by sine Q. So the correct answer for this one is just going to be letter C. 32 over sine Q is what side QS is equal to. All right, so I hope you enjoyed this video. If you did, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Also, check out, like I said, the solutions and the problems to the first two videos covering May 2025 test problems. If you have any comments, questions, additional solution methods, feel free to leave them in the comment section below. And otherwise, just a reminder, if you're looking to improve your score, specifically with regard to Desmos, please check out my Ultimate Desmos Guide to Digital SAT Math. It has over 3.5 hours of tips and tricks, and it's now up to over 50 example, practice problems to help you ace the Digital SAT Math section.